Okay, thanks everybody. We're going to get started. Thank you so much for coming tonight. My name is Matt Gillis. I'm the Environmental Program Manager for Varian. Again, we appreciate everybody taking time out of their schedules to come here. We have lots of folks from different entities here, so thanks again. Before I continue, I'd like to point out that this presentation is being broadcast virtually. It's also being recorded. So when we're done here tonight, we will post it to our project website. Next slide. Okay, so this meeting is a little bit different than our previous ones in that it's not mandated from sort of an MCP standpoint. The primary purpose of tonight is to discuss the biannual status report. As the name implies, the biannual status report is done twice a year to provide an update on the different treatment systems that are being implemented at the site. So, and also in addition to that, Jason's going to provide an update on the release abatement or the immediate response action plan for the asbestos abatement, and that's impacted some of the thermal system. So we got a thing up here. I don't know what that is. Anyway, that's pretty much it for me. I'm going to turn it over to the technical team who are here. I'll even let them introduce themselves, most of them from Jacobs, but we also have licensed site professional who's independent, licensed site professional Matt Hackman, who's here in case he's needed. So I'll turn it over to Jason.
While Jason's coming up online, I just want to point out if anybody is online and participating, we would not be able to hear you in the room during the questions and answers, so type your questions into the chat and we will read them and answer them when we get to the questions.
Perfect. Thank you. Well, welcome. For those that I haven't met or spoke with, my name is Jason Cole. I'm with Jacobs. I am a subject matter expert in thermal remediation processes. I'm supporting the project and work along the Building 3 source area. And just to kind of recap where things are with this remediation strategy for Building 3, in situ thermal treatment has been selected as the primary technology to deal with the residual source material, the contaminants which are present in the subsurface. This is an aggressive technology designed to remove the contaminants in their form. Knowing that this site and the source area is beneath the building, we've coupled this with in situ bioremediation. So once the thermal treatment work is performed to remove the bulk of the source material, in situ bioremediation, which is a process will follow. In this particular case, we're supplying food for natural microorganisms to eat the residual contaminants that are essentially left behind. There are others that we'll talk about. Carol and Raymond will pick up various pieces of in situ bioremediation or in situ biotreatment. It's part of a theme that is being used in this remediation sequence for the Varian project and complementary to the thermal work that's taking place ahead of it. And then finally, continued operation of the soil vapor extraction system. This is a system that's placed in and around the existing CPI building, and it's mainly associated with maintaining potential concentrations of solvent inside of the building space that's safe for the occupants, it's safe for use of the building, and it's safe for human health exposures. The purpose of this little update here is just kind of give you a thumbnail of where we've been since we've last pulled together this last PIP meeting. And essentially, the thermal treatment system construction is underway. And kind of a high-level overview, the CPI stock room relocation is completed. For those that have seen prior presentations, essentially over half of the thermal remediation system is installed below the building, and to install that system we needed access to space inside of the building, which was occupied by CPI's operation. There was a shell game of move and rebuild that's now been completed. The stock room is free. We're ready to move into the stock room as the outdoor drilling operations are wrapped up and then construct the rest of the system. National Grid, this is an electrically powered heating system. We're going to use a fair amount of electricity. National Grid has updated the design for our feed. We're working through the final phases of contracting to get that service established. So there will be some utility work taking place on the site to set up and get us ready to go. Outdoor construction remains ongoing. There's a lot of work, staging, logistics with working in and around this particular facility. It's very constrained, it's very tight. Some of the equipment that we'll be mobilizing is large. The drill rigs take up quite a bit of space, so there's been grading, there's been earth moving, there's been demolition of some retaining walls, all simply to get material in and around to construct this system. The indoor drilling planning is in progress. We'll talk a little bit about that on the next slide. And then finally, the update for permit to utilize a portion of the Route 128 right-of-way from the Massachusetts Department of Transportation has finally been approved and in place. And that's essentially to provide a little bit more space on the north side of the building, right along the 128 fence. We're going to bump it out, we're going to level it off, and then use that to stage some of this large remediation pieces of equipment and construction of the rest of the system. The asbestos-containing material identified through the site drilling operations has been removed. The immediate response action plan will be filed and completed in the latter portion of October. That is a document that will be open to public comment, but not necessarily a public meeting. So look for that, and a notification will be provided once that's up and available for comment. And then the final piece of it is we're looking to get things moving with respect to modifications to the building's ventilation and heating system, and that's as a result of some of the drilling observations that we've made outside. So let's go to the next slide on that. So really the slide title here kind of sets the stage for the field conditions altering our outdoor construction progress. And I want to call attention to this pink boring here down on the lower portion, thank you. That's HC14, that's a diagonal boring that was advanced from outside underneath the basement below the portion of building 3 and out into what we believed was the edge of the treatment zone. Some additional source material was hit out the terminal point of that boring, HC14, and as a result of that observation, we're looking to potentially pivot the strategy in which we're going to go ahead and heat this boundary. If we look, this dash line, which kind of moves around, this is an engineer drawing. It's a little bit more complicated than the ones we've used and I've used in prior presentations, but it starts to get a little bit of the complexity of the stock room, the alignment of heaters, the alignment of extraction equipment that we're going to be coming forward with. So we're currently working through some simulations of being able to access this area and get it prepared. We identified this material and encountered this material towards the late portion of May. When we hit it, it was an obvious point to pause because we were getting prepared to do that ACM removal, so we put stuff on hold. It also identified when we were out drilling that we needed to do a little bit more associated with the ventilation around the building and the proximity to the space. And we wanted to make sure that we had these provisions in place before we took drilling operations indoor. HC14 was outdoor, and as a result, we've gone through and subjected the building to some additional HVAC analysis to look at airflow, to look at air exchange. And as a result of that, we felt that to get into that stockroom space, maintain safety of the employees doing the work, as well as CPI operations, that some changes to the HVAC equipment in that portion of the building were necessary. We're working through the final design phases of that. The equipment's been ordered. We're looking to implement and get that equipment installed towards the portion into October. Let's go to the next slide. And then kind of overall construction status, the HVAC system is underway. We're looking to restart the construction and completion of HC14 and 13. Those were the 2 remaining outdoor borings in the mid-October timeframe. Once we're completed there, we'll take those drilling operations back inside and look to progress the rest of the system construction from inside the stockroom. Some work will be occurring along 128 in probably the weeks ahead to move that fence line and some grading to take place and essentially prepare some space for the overall staging of the remediation equipment. And then once we're back into the stockroom, our drilling operations will begin and looking at about a 6-month duration to get that indoor drilling work done. With that, I will hand it over to Lauren. Lauren's going to talk a little bit about the Tozier Road, and then. Oh, yeah. So this is a schematic here. Kind of, this is the east side of the building, and this was some of the work before the site prep was done. This is a schematic of the ducting, which is going to come up the side of the building, up to the roof to move as part of the ventilation and air exchange systems that are necessary, that we felt were necessary to get into this building space. But this is down kind of at the basement level. The HC14 boring kind of originates kind of where that north arrow is. If you can see it projecting underneath the foundation and diagonally in under the space. So very constrained space to get in there, but we necessarily, we wanted to make this change before we got any further along, and the asbestos abatement really kind of gave us the opportunity to get in and do this. So now we're ready to move forward to wrap these locations up and then move inside. So, Lauren, thank you.
Hi, for those of you who haven't met me yet, my name is Lauren McKinley. I'm also with Jacobs, and I am the project manager for the Tozer Road portion of the project. So I'll be talking to Tozer Road, and just as a reminder, Tozer Road is right here. It's down gradient of the source areas. So as a reminder, the remedial option that we will be implementing at Tozer Road is a permeable, reactive, and absorptive barrier. And this bottom diagram shows how this barrier will work. In this diagram, the barrier is depicted as the purple oval, and groundwater flow is shown as the blue arrows. So as groundwater flows down gradient from the source areas, it will move through the barrier, and when it hits the barrier will trap the contaminants, treat the contaminants, and allow groundwater to flow through. So it's important that this isn't going to stop the groundwater flow. It's going to allow groundwater to continue flowing through, but treat the contaminants and stop the contaminants from migrating further down gradient beyond Tozer Road. So in order to get to the installation of the barrier, there's things that we need to do. We need to conduct some investigations that will provide us some additional data. So we've collected data, high-resolution data, and some soil and groundwater data, and we're still continuing to do some additional investigations. And once we have all that data, then we'll be able to refine the design of the barrier. And just want to point out where the barrier is depicted on this figure is not necessarily the exact location where this barrier will be installed. Once we have all the information we need to refine the design, then we'll know where the exact final location will be. Once we know the location of the barrier, then we'll be installing some new monitoring wells, both up gradient and down gradient, of where this barrier will be installed, and these will serve as performance wells. We'll collect some groundwater samples from these performance wells so that we can get a baseline sample and be able to compare that once the barrier is installed. We'll then begin installing the barrier, and the way that we're going to do that is through injections. And the top diagram up there illustrates how the injections will occur. So wherever we're going to be, in the area where the barrier will be installed, we'll be drilling approximately every 5 feet down into the water table, and through these boring points, we'll then be injecting the amendment into the subsurface. And the spacing such is that as this amendment is injected at different points, it ultimately overlaps so that you end up with a permeable treatment zone in the area that you're doing the injection work. We'll be monitoring the whole time that we're doing this injection work. And then once the injections are complete and the barrier's been installed, we'll then go into what's called post-remediation monitoring, where we'll be collecting groundwater samples from the performance wells that we had installed prior to the barrier installation. Excuse me. Next slide, please. So right now we are in the midst of pre-design investigations. And like I said, this is important. We need to get additional data so that we can refine the design of the barrier and make sure that we're installing it in the optimal location to treat the groundwater as it flows down from the source area. To date, we've completed what's called a membrane interface hydraulic profiling tool investigation, which is a mouthful, so we refer to it as MIP. And this was done over a long span of Tozer Road, from 16 Tozer Road down to 39 Tozer Road. And this is where we collected a lot of data, high-resolution data, and it gave us information on contaminant concentrations, distribution, how groundwater was flowing. Following that, we went back out and did some additional drilling activities. We installed 7 temporary soil borings through a method which is called direct push technology drilling. And that's shown in the top picture. When we did these temporary borings, we collected groundwater and soil samples, and that picture shows us purging some groundwater before the collection of a groundwater sample. We also installed 4 permanent monitoring wells, and that was done through a different drilling technique called sonic drilling, and this bottom picture depicts that activity. So next steps, some of the next immediate steps that we'll be conducting is we will now be going back out to collect some groundwater samples from the newly installed wells and some existing wells. And then once that is complete, we'll be deploying some flux meters down 4 wells. And these flux meters will stay in place for 2 weeks, and they collect data that will help us understand where the greatest mass of contamination is flowing through Tozer Road. And that work will be being conducted in October. Once that's complete, we'll be able to have all the data we need to refine the design of the barrier, and at that point then we'll know where the optimal place for the barrier to be installed is, and then we'll be able to install the additional groundwater monitoring wells, which will serve as the performance wells and collect our baseline samples. And so that's the update on Tozer, and now I'm going to pass you over to Carol.
Thanks. So I've met many of you. My name's Carol Mauder, and I'm the Senior Technical Consultant on the project. So that means I'm engaged on all these different projects and technical oversight on the different sites, but I'm going to specifically talk to you tonight about PSL 10 and then the update on the bedrock work. So PSL 10, as a reminder, is at the southern end of the site, south of Building 5. It's in that open parking lot. And we're going to be constructing a subgrade biogeochemical reactor. And we've made some progress here in that we've selected both the driller as well as the civil contractor that's going to do the installation for us. And we've also had the utilities in the area marked as well as the property boundary. I want to point out the dashed lines here. That marks about a 50-foot wide easement for the city of Salem. And I also want to point out we've got a 30-inch water main. We've got some monitoring wells and extraction wells, as well as some conveyance piping that's going to go through that area to the subgrade biogeochemical reactor. And with that being installed in the easement, the city of Salem has asked to have a third-party consultant do a review of the work. So that's where we are now. We've got folks under construction to do the implementation, and we'll be giving the city of Salem, or we have given them, our design work, and they're going to have a third-party consultant do a review. They anticipate it taking about 3 weeks to do that review. We don't know yet what kind of comments they're going to have, but we are hopeful that we'll be installing this still this fall, going into December, and be operating later this year. But we're on hold right now until we get comments back. So that is the update on the SBGR at PSL 10. Next, I want to talk about bedrock, and we've got a little bit more of an update here. So the bedrock area that we're looking at treating is right here. It's in the middle between Building 3 and Building 5, and it's an area where contaminants from those original source areas have flown down gradient and gotten into the deeper bedrock. So since early July, we've been doing our pre-design investigation. So I want to walk you through what we've done and what some of those results are showing us. So we advanced 5 bedrock boreholes. You can see the drill rig on the left-hand side of the photo. And then here's an actual photo of one of the cores, and we've got our site personnel actually looking at the core, logging it, looking to see where does it look like we have bedrock fractures. They also have a photoionization detector, which they run along the core, and it tells us if we've got elevated concentrations of VOCs, or it gives an indication of where we might have elevated concentrations of VOCs. In addition, we do some downhole testing in those bedrock cores, and what we're looking for are indications of where there might be fractures, where contaminants could be moving, where there's water flowing, or maybe there's just fractures that there's really not a whole lot of water flowing. Based on that information, we do Packer test. What a Packer test is we put some equipment down the hole. We'll put packers, inflatable packers, to isolate above and below a zone that we're interested in. We'll then start pumping water from that zone, and we measure how quickly water comes back in and replenishes it. So that gives us a better indication, a quantitative measurement of how much flow we have in a fracture or we don't have in a fracture. Once we do that, and we also collect a groundwater sample from that zone, so we can determine not only is it flowing, but does it have contamination in it or not. We'll then determine which zones in that bedrock core we want to install our monitoring wells, what zones we're going to monitor, and then where we want to do our injections in. So that's all part of the pre-design investigation. On the next slide, I'm going to walk through some of our findings. So there's a lot of information on here. These big orange circles are where we did, where we have existing bedrock wells, the ones with the open yellow in it. Those are our new bedrock boreholes where we've done some of our Packer testing. Go down to the next slide. So here's our first boring, and it might be kind of hard to see, but what we have in the table is 3 zones where we did our fracture testing, and again, that was based on what we saw in the borehole when we went down. We selected 3 zones to do our Packer testing, and over here where it says fracture zones, you'll see one of 2 words. Either you'll see the word transmissive, which means it looks like there's quite a bit of groundwater that's flowing in that zone, or you'll see the word tight, which means there's really not. You might see a crack, but there's no groundwater that's really flowing through there. In addition, you'll see a color. If it's green, it'll indicate that there's elevated concentrations of VOCs in the sample, and if you see black, there's not elevated concentrations. So you're going to see colors to indicate higher or lower concentrations, and then words transmissive or tight to indicate whether there's groundwater flow. So in this first boring one, we had 3 zones, and in the Packer test, they were all transmissive. So there was all water flowing through them. And in all 3 of those, we had elevated concentrations of VOCs. As we move further south to the next boring, you'll see another green dot, and a green dot means we have concentrations somewhere in that boring that were elevated. When we look at the 3 fracture zones, all 3 of these were tight. So in that location, there really was not a lot of groundwater flow, but in the top 2 where it's green, there were still some elevated concentrations, but it looks like there's not a whole lot moving in that zone. We go down again. In this boring up gradient, we had a combination of things. We had the top 2 more shallow. They were transmissive, but they really didn't have high concentrations. The deep one was tight, not a lot of flow, but there were some VOCs in it. So I know this is kind of tedious, but I want to walk you through what we're seeing in the data and how it's affecting our design. So the next one is the furthest south boring. You'll notice a blue dot. That means we didn't have any concentrations of VOCs above our bedrock criteria, and all 3 of these were transmissive. So at that end of the site, we've got elevated groundwater flows going through it, but not a whole lot of VOCs. So this is important because previously, when there was some geophysics done on the bedrock boreholes, we saw tight fractures. So the anticipation was that there was not a whole lot of movement of contaminants. It was kind of like a dead-end fracture. Contaminants moved in there, kind of got stuck. And the plan was to go in and do in situ chemical oxidation, which is what had been done before. But now that we see this transmissive zone, our conceptual site model is that we have contaminants up in the source area. They migrate down into bedrock, and it's not stuck there. It continues to move down gradient and then up wells along Tozer Road. So it's really a migration pathway. It's not a stopping point. So with that, we're recommending a slight modification to the remedy. We were going to be doing in situ chemical oxidation, and instead we're recommending in situ chemical reduction, so ISCR instead of ISCO. The reason that that is important is that up gradient, building 3, building 5 area, we're doing anaerobic remedies. Down along Tozer Road, we're doing an anaerobic remedy. So I want to do something that's going to be complementary, working in coordination with the other remedies, because contaminants will get into bedrock, migrate down gradient, and then migrate to Tozer Road. So we've talked about this with DEP, and they agree that it is not a substantial change. So we're recommending using a combination of zero-valent iron and emulsified vegetable oil. These are materials that we are using elsewhere at the site. We'll be using EVO up in the building 3 after thermal. We'll be using ZVI and EVO in the building 5 area, which Raymond's going to talk about. And we'll be having ZVI along Tozer Road also. So it's consistent with what we're doing elsewhere. But with seeing this migration pathway, we think it's really important to treat that area with a similar approach. As far as next steps, we've installed our monitoring wells in some of the key zones. We'll be doing sampling. We'll be doing some additional geophysics. So we did geophysics downhole, but we're going to be doing some surficial geophysics to look at how these fracture networks connect to decide our final location of our injection wells. Then we'll be injecting amendments and doing our monitoring. We anticipate installing our wells later this year, both the injection and the monitoring wells, and then early next year, winter, doing our actual injections of the amendments. And that's it for the bedrock. And I'll be handing this over to Raymond.
So that was a lot of information, so we appreciate your attention. So we're kind of heading into the home stretch here. I'm going to talk about Building 5, and as Carol mentioned, Building 5 is also an area where we're doing bioremediation using emulsified vegetable oil and zero-valent iron to act as treatment. In this area, we're going to be installing some additional wells, and as part of our pre-design investigation, but we're combining that with treatment at the same time. So we're looking to utilize treatment and investigation at the same time. To do that, we're going to do a pressure injection of the amendments that Carol talked about, the zero-valent iron and the emulsified vegetable oil. Because we're doing that pneumatic pressure injection, the first step we wanted to do is take a look at the building and make sure there weren't any structural issues that would be concerning. If I didn't mention it, we're going to use vertical wells installed outside the building. We're going to also use fans of wells installed from outside of the building at angles under the building. So there'll be pressure injection at an angle under the building, and there'll be pressure injection right next to the building. It's going to be done at depth, but we still wanted to have a professional engineer go in and take a look at structurally, is this going to be an issue with the building? That inspection was done in August. We have the results of that report, and it indicated to us that there should not be a problem, and the engineer has certified that there should not be a problem with that. So that is done. And we plan to start doing this work once the more down gradient treatments are in place to prevent, because this is a pressure injection. It has the potential of moving stuff around. So we want to make sure those further down gradients, whether it's the bedrock or the Tozer Road remedies, are in place before we do this pressure injection. So that will be done in the near future once we have those things in place. And again, we'll be doing that pre-design investigation and the treatment at the same time. Down the road, we'll also be doing a second round of treatment in this area, some shallow treatment that will probably happen in the spring of 2025. Next slide. Last treatment area to talk about is the reactive core mats at Stream A. And if you recall, we've talked about these a couple of times. These were installed back in the fall. These are two carbon filter mats essentially put over the seeps that were seen on the edge of the stream bank. That was done last fall. We've continued to do monitoring of those mats to make sure there's no erosion and they're still in place and functioning as they should be. And that monitoring is indicated is the case, that they're still functioning as they were designed. We also talked about during the last couple of meetings is a drain pipe we found during the installation of one of these mats. We did do a video inspection of that drain pipe, and as we expected, we found that drain pipe was an old drain pipe. It's collapsed, seems to be getting groundwater in it, so it doesn't pose any issue that we need to be concerned about. We also, at the same time, looked at some drains that were in Longview Terrace and Longview Drive, just to make sure those were not drain lines that were heading towards the stream and part of this pipe system, and that was not the case. So that work is being done, and that information is included in the status report that we just submitted. And then lastly, we are continuing to do monitoring of the stream itself. We're sampling stream water upstream of these mats and downstream of the mats. There's also a shallow well right next to the mats that we're monitoring to make sure things are not changing in a manner that's going to be of concern. Ultimately, we want to show that these are changing as upstream remedies are implemented, though they're changing in a positive way, but that monitoring will continue as we move forward. Next slide. So up here, we have an estimated schedule that we have put together for each of the treatment areas. You'll see information about design, when system installation is going to happen, or if it has started, when the start of treatment is expected, as well as then ongoing monitoring of treatment. So you'll see that the design for the thermal is complete, installation is in progress, and some of the other ones also. We expect the next one to be implemented will hopefully be the SBGR this fall, once we get through that review by the city of Salem. And with that, I will turn it over to you, right?
Thanks, everybody, and I appreciate your patience. I know that's a lot, and I'll give you a chance. We'll get into some questions in just a minute. For those of you who have not met me before, I'm Amy Brand. I'm a public outreach specialist for Jacobs. I just wanted to cover what reports are available and coming up, and what's and how to find more information. So this presentation was a overview summary of the data that's in the revised Phase 4 status report. That was issued in August. It is available on MassDEP's website, which is there at the bottom. There's a hard copy also at the reference desk at the public library. And those status reports, I think we mentioned at the very beginning of the meeting, will come out every 6 months, and we intend to have public meetings kind of coinciding with them to present the status of the treatment systems. Also coming up for public comment and review, we mentioned the asbestos abatement. This is basically a completion report. So that we'll be announcing, we'll send out a public notice when that's available for review. And there's a 30-day public comment period on that. If you want to read it and submit your comments, you're welcome to do so. There will not be a public meeting for that per se. And again, that will be at the Beverly Public Library and on the MassDEP website. Speaking of websites, if you haven't been to our project website that we set up, the information here on the right-hand side, we update the homepage of that monthly with the treatment progress that's going on. And if you're on our email list, you may get that by email as well. The same information goes on to the homepage of the website. This is where we post the public meeting videos, so you can go back and look at the presentation. You can go back and review these meetings, or if you missed one. There's also just a lot of information in terms of an overview of the environmental investigation, descriptions of these treatment systems that we're installing at these different places, links to the MassDEP website, links to fact sheets put out by MassDEP and the U.S. Environmental Protection Agency that are like citizen fact sheets to explain some of these treatment technologies. And there's forms for submitting comments and for getting in touch with us. And then finally, we do have a project email address as well, Beverly Site Cleanup at jacobs.com. So if you want to send a question or a comment to the project team, you can send it to to that address. With that, I'm going to go to questions. We covered a lot, and I don't want anybody to be shy about asking anything related to what you heard, even if it's like, I just totally didn't get that. Could you explain that again? We went through a lot of information. I want to refer you again to, we're doing treatment at 6 different areas. These areas are source areas up here, building 3, building 5, and the PSL 10 area. Those are source areas. And then contaminants move down gradient through the bedrock area that Carol discussed. And then this permeable barrier area that we're talking about around Toja Road. And then the stream A seep was further down here that Raymond talked about at the end. So those are the 6 areas where we are putting in treatment systems. And with that, I will open it up to questions.
And I assume we want to use the mic for questions, right?
Yes, Matt Hackman, who is our project LSP, licensed site professional, he is also, will be moving a microphone around the room. And that's to reminder, this is a hybrid meeting, so there may be people online listening as well, and that's to make sure that everyone here in the room can hear, but also people online can hear. So. Okay, make sure it's green.
Yes.
Okay,
It's green.
go ahead.
Hi, Jerry Paracella, State Rep. Jason, if I understand, it sounded like you did some drilling and then came upon some asbestos. I was wondering, have you come upon any other material that we should be concerned about? And if you do come across material during this process, what's the plan for cleaning it up?
So, is that right?
Good.
Yeah. There we go. Yes, we did come across asbestos, and that material was cleaned up and closed out and the 25th, 26th, no, excuse me, the 16th of August was the last one when that was all wrapped up. The material that we did come across that I indicated that HC14 was entirely consistent with what we know of the solvent, the source materials previously encountered in other groundwater areas, other groundwater locations. Generally speaking, when we implement this type of remediation technology and characterization, or the construction data shows different than the characterization data, a lot of times the system, and one of the reasons why, a lot of times this for this particular technology for thermal remediation, it can accommodate a different type of contamination. Within threshold, there's certainly some balance points there. The bottom line is we haven't seen anything different with the exception of the asbestos in the superficial soils. That was a separate removal action. Material in the subsurface soil and groundwater is entirely consistent with what we've seen to date.
I'd just add to that, we did find a small area of oil in another on the other side of the building. And to answer your question, there's a process in place that if we are at this site and we, like Jason said, what we saw at HC14 consistent with what we understood about the site. There's a process in the MCP that if we come across something that is not consistent with what we know about the site, we need to report that. And a good example is that very small area of oil seems very limited because we drilled a bunch of wells in that area. There's a really tight network of wells. We had one well where we saw some residual oil, similar to what Jason said. Oil is very amenable to thermal treatment, so it's gonna cook it off, for lack of a better term, and recover it. So there is a mechanism in place that if we see something different than what we understand about the site, and it hasn't been reported before, we need to report it to the DEP. If it's above, there are several different thresholds. If it's a hazard, there's a different question than if it's just a little bit of oil, which was what we saw.
And that's one of the reasons that Matt, who's sitting right next to you, we lean on him for, the protocol for it. These folks, by and large, know how to handle most of that, but if anything they wouldn't, they would go to Matt, and he would sort of point us in the right direction.
Mayor Kale? No, okay, go ahead.
Thank you.
Go ahead.
Along similar lines, when you were presenting on the bedrock being tight versus transmissive and that being kind of a curveball, or not curveball, but not what was anticipated, is changing of the remedy that is being used. Is that an obstacle? Is that worse? Or is this going to just be a change? Like, what is it going to extend the timeline? Like, I just want to.
No, and we look at it as a modification, and that's why we call DEP as if it was considered a significant change, it could take steps backwards in the regulatory process and have to go through things. So we wanted to talk through that. We talked with Matt, we talked with DEP, and they both agreed it was just a modification. So no, it's not going to affect our time frame. It's not going to do anything. And I would say with these more transmissive fractures, doing the reductive approach, which includes that zero valent iron, is better, not only because of the anaerobic up gradient and down gradient, but also that zero valent iron sticks around longer, whereas a liquid injectant like the permanganate is going to flow with the groundwater. So this gives a treatment that's going to stay more in place and treat as other groundwater flows through there. So I would say it's a better approach with these more transmissive fractures. They are complementary.
I've got one. So going back to the heating treatment and stuff, and we had talked about some modifications that needed to be done as far as with CPI, both the air and HVAC and that type stuff goes, and a few other things you found. Is that going to do anything with our timeline as far as what you're projecting for it to be done?
No, not necessarily. I mean, it is projecting a timeline. It's delayed our ability to get into the stock room and actually start that indoor drilling. But I think looking at it from our observations with 14, it allowed us to get a lot of additional provisions in place to really assure the safety of the operations that take place in the space. I mean, when we look at, spatially speaking, we're talking about putting one of those drill rigs in a room probably not much bigger than these columns and angle drilling. It's a diesel operated machine. There's solvents in the subsurface. We know that's the case. That's why we're there. So that additional air exchange capability, the additional treatment capacity offered by these supplemental pieces that we're bringing in is going to pay itself forward. So as far as schedule, it's still running the same course as far as duration of time to get it done. It's just that we're getting a later start into the building than we initially envisioned, which is, giving us that 6 months from when we basically get indoors.
Thanks, Steve. Mayor Mike Cahill, I had to come from another meeting, so I'm apologizing in case you already covered this. I will go back and watch the presentation just to do my own due diligence. But when you find something like asbestos, which, very familiar with asbestos, when you find it in the place and the way that you did, do you have a sense of where that would have come from?
I mean, historically in these types of facilities constructed in the 50s, no, it may have been part of a building. It may have been part of siding. It may have been part of roofing materials. I mean,
Just ended up getting plowed over.
It just ended up getting
Yeah.
buried. I
Yeah.
mean,
Which makes sense.
that's pretty typical.
Yep. Gotcha. Thanks.
Yeah, I just, could you go back to the diagram when you were showing us the treatment thing? And you had the fat arrow there.
Oh, yeah. There we go.
So just explain, is this what you're talking about, the fat arrow there? That's
Yes,
the
it's
horizontal. You were
it's
talking
a
about oil. What exactly, so when you were horizontally drilling under a building?
yes. So So if I can point to the building space, and Laurent, maybe you can follow.
Yeah, Jason, if you would show kind of the outline of what's building.
So Laurent, I'm going to start at 12 o'clock here at the top corner of the building. Here we go. So this is, as I come down here, this is the building 3 exterior wall, and then it continues down along this line. And then what we have around, this is the outside of the building up here, again, back to 12 o'clock, kind of coming down along. This is 128 right across the north. And then everything else really to my left, which would be to the west, is indoors. This is indoor space. This is the stock room that I spoke of earlier. This is the area that we now have access to that, the renovations took place and we were able to vacate CPI's equipment. So this particular boring that we were speaking of, Jenna, the one that you asked about, was a horizontal boring. It was run at about 28 degrees, if I remember correctly. So fairly shallow, fairly long, diagonally underneath the building, underneath the basement, because this area of the facility, there's a subsurface basement, so we were down below the foundation. So very, very shallow angle, very far out. Towards the end of where this boring was terminated, we actually picked up some of the additional solvent, additional source material. And when we see these types of scenarios, source material anywhere in the inside of this box is generally fine because you've got a heated boundary, the heat takes care of it, the heat helps drive that contamination. Encountering the material on the edge of the treatment zone is requiring us to reconfigure and to relook about potentially extending this boundary, to include a little bit more material here to ensure that we've got kind of a heated envelope around that material. It's a little bit of a challenge because this area of the facility is very, very heavily spatially constrained. You might ask, well, hey, why didn't you come in from maybe this side here and try to attack that as part of the overall system construction? There's no physical way to access that portion of the facility. There's loading docks. It would be massive demolition of existing infrastructure. And we talked a lot about this in kind of the design of this system. If there wasn't a building here, this would be a pretty easy problem to solve. But we don't own the building. We have to work around the constraints of that space. And as a result, this boring being advanced, really from a very small alley. In fact, this little, on the other side of this gray is a giant bank of transformers, which provides, power to the facility and to itself. There's a fiber optic line in there. There's 2 gas lines that fuel the boiler. There's a whole bunch of stuff that makes this really kind of a puzzle. And at some point in time, when maybe in the tag group, I can bring the 3-dimensional model up of what this spatially looks like. It's incredible. It looks like spaghetti. And if you can envision this with all kinds of lines, we flip this up and we've got them now moving at different angles, different distances into the subsurface. So what we'll be looking at now is being able to reconfigure some of those spatial access points to provide a little bit more heating down at the terminal point of this boring, and then essentially use that as a basis to help, drive the contamination.
Like the coils, right? These are the heating coils that you put in.
Yes.
So to be clear, to generate the heat, you have to have these heating coils implanted, right?
Yes.
So no problem, or less of a problem in the building, which you have been putting the coils in. Because you encountered this area, so what does that do to how you're going to implant the coils? I guess, is that the trick? Is that the puzzle?
Actually, the puzzle piece is the hole that the coils are placed into. So when we drill a boring to install that infrastructure, it's steel. It's a steel pipe. It's sealed. And then the heating coil essentially goes inside of that steel pipe. So right now, this steel pipe isn't completed. It's not at its final depth. It's not in its final space. The angle and the length of the boring is set, but we have the ability to go further, to pull back. We may even potentially, seal this one up, and rather than use that space to take this particular angle, we may reconfigure and come in at a slightly different angle to reorient the heaters themselves. It's very, very challenging to see when we look at this in a vertical sense, and you see these dots in the map. It's very easy. You have a heater, you have a heater, you have a heater, you have a heater. They all run vertical, and we think about it kind of being a bunch of pegs in a board, for example. When we move this to an angled approach, each one of these lines may represent anywhere from 4 to as many as 6 heaters that are at different angles going into the ground. So while this may represent a single line, HC14, it was actually HC14B. It was the second of 5 borings that are associated with HC14 on that, angled fan, which allows us to be able to heat down to the desired depth and into the desired spatial piece. So the three-dimensional space is kind of crazy when we get into working at these angled systems. And again, it just speaks to the complexity of trying to treat underneath the building space and an occupied building space as well. So we're evaluating the options that we have and how we can reconfigure. The other kind of, I would say, competing factor is that if you can look where this kind of HC12 is and comes across, there's actually a building. There's another story down below the stockroom. So we're dealing with a couple of different elevation planes in which these borings are entering. So getting that reconfigured is going to take us a little bit of evolution, especially being able to fit it kind of within that stockroom. So long answer to a fairly simple question. So.
Other questions? Barrett and then Tiffany.
I should let if there are non-technical questions, I should let those be answered first.
Well, Tiffany's with DEP. Go ahead, Barrett. Then we'll,
I guess my
go ahead.
question was, what, and the HC14 borehole, was this on? Or?
Green?
Yeah, there we go. Was the HC14 source material, was that encountered above the water table?
No, it's below the water
Below the
table.
water, okay.
Yeah. It's below the water table. Okay. That was an easy question.
Hi, Tiffany Duell with DEP. I just had a sort of a point of clarification on, and this is on the bedrock slide that shows the transmissive zones and the tight zones. And Carol, thanks for your excellent explanation of the pre-design investigative activities. The point of clarification is just to point out that, the difference between the green and the black is not necessarily like there's VOC and then there's not VOC, which was a little bit implied. It's more that the stuff in the black could just be below the target treatment. Because I know at least one of those black, I think it's the 125 to 151 boring 2, was actually, or maybe it was boring 3, it was actually pretty high, relatively high from an objective perspective, but it's just below your presumably
Our
5
treatment
milligram
goals,
treatment,
right.
yeah.
So in the phase 4 design, we established our treatment goals within the bedrock area. So the black, I don't believe I said non-detect, and I apologize if I implied it, but they were low concentrations, meaning they are below those treatment goals versus above the treatment goals. So thank you for pointing that out.
And I just add that we installed wells at each of these points, and we're going to go back and take groundwater sample to look at those with a little bit better sampling method as opposed to this screening grab that is done in the Packer testing.
Other questions? It's a lot. It's okay. If you have other questions, it's fine. That's why we're here.
And we'll stay around. We're happy to answer questions if people are more comfortable one-on-one. That's fine with us. Not everybody can stand up and ask a question at a meeting.
And no questions online.
And there are no questions online. I didn't put a slide together on this per se, but we are now, we're past right now the phase of the reports and required public meetings for at least in this part of our investigation and treatment. So right now we are into doing, as we outlined in our public involvement plan, we are doing public meetings on these as these status reports come out every 6 months, and then in between those we'll be continuing with our technical advisory group meetings. Those are also held here. They are open to the public. We kind of gather more around a conference room table. And so I think the next one, I need to reach out, but it will probably be January, I think, rather than December.
So wait, Amy,
Go ahead.
point being that given where things are in the process.
Mm-hmm. Thanks, Matt.
So point being, given where we are in the process, essentially we're meeting quarterly.
Right.
2 PIP meetings every 6 months, alternating 2 tag meetings.
Right.
So, yeah.
Right.
And we'll keep on that schedule unless there's a need to go more to, unless there's a need to do something in between.
That's right. And there may be points along the way that there is a required public meeting or a public comment period. Of course, we would have those. But otherwise, we're doing this, we sort of outlined this quarterly schedule. So again, there's an email that goes out if you're not on our email list and you want to be. There's an email that goes out once a month with just some bullets. And those are also posted on the homepage of the website each month. And there's more information there. Any other questions or comments? Barrett, go ahead.
If this is the venue for technical questions, we don't have to do. I'm just not really sure what. Okay. All right. So I guess, Jason, one question that occurred to me, and I apologize if this is in the report, I didn't pick it up. So when the thermal treatment is over, when we're through with our heating phase, and we're getting into letting the aquifer cool off, what temperature do we have to get to before the bio component kicks in?
So generally speaking, 40 degrees centigrade
40, yeah,
is
okay.
the threshold.
Yep.
We will likely start to see natural biological activity kicking
higher than
in at a higher
Yeah.
temperature in the down gradient fringes. When thermal treatment occurs in aquifer substances, aquifer materials, there's a lot of organic materials that are naturally released to the subsurface. These are natural, components of soil. They're also capable of driving these biological reactions. And we see this in a lot of sites that have undergone thermal treatment. We'll take advantage of that, obviously, with the substrate injection. That'll follow probably, I would say in the 60 C range, maybe a little bit closer to 40.
And what does the modeling show in terms of timeline to get to those
So
temperatures?
all of these sites heat and cool at different values and rates. We'll likely need to be looking at field data to be more predictive of what the actual cool down rate is. It will be dependent on the flux of water, so how much groundwater is locally flowing through the treatment zone.
It can be pretty high.
It can be, but sometimes it's deceivingly low.
Yeah.
So you start to see, hey, we've got a contamination, or we've got the source area, and you look to see that cool down phase and expect it's going to be, 4 to 6 months, and it's more like 8 to 12 months. The bottom line is the residual heat, regardless of that temperature decline, is providing benefit because organic material has been released to the subsurface, and that cooling rate is kind of, it becomes what it is. We don't want it to happen any faster, really, because you're still taking advantage of those elevated temperatures. There's still hot groundwater moving down into the bedrock zone and continuing to heat that provide that additional energy, that additional temperature increase to the bedrock zones. So while we don't see it specifically in the area that we've heated, we see those benefits on the periphery. So a lot of times that cool down rate is what it is. We monitor, we have provisions to monitor, and when we think we've got the temperature in that treatment zone where the benefit of substrate is going to come forward is where we would come and address.
And I just want to add, it also depends on where we're seeing elevated concentrations, right? So just because we did thermal doesn't mean we're doing bio everywhere. We're going to look at what are the concentrations
Oh, I see.
below
So
where the
polishing is going
thermal.
to be based on where the residual mass is. Okay.
Exactly. So if there's nothing, if there's not much there, we're not going to add it. But in areas where it looks like it might be feeding that bedrock and going down, that's where we'll want to do the injections.
So with the HC14 issue, and I apologize again, this may have been in the report, but I guess there was some concern about a brief pulse of indoor air quality in Building 3 at one point. Was that related to the HC14, or was that just?
It's no. I mean, they are definitely related, and that's what drove.
I just didn't know if when you were pulling core from HC14, like, was that when you were getting big?
Yeah, it was.
Okay.
It was. So that was related. That's what kind of. Yeah.
We got the engineers talking to each other now.
Yeah.
If you're not following, that's okay. But
So
explain for other folks a little
as we've mentioned in prior presentations, in preparation for work inside of CPI's building in the stockroom, we installed a continuous gas chromatograph, basically a very sensitive piece of equipment to monitor air concentrations inside of the building space in 10 different locations. That system was moving along, collecting baseline data. We were getting ready to wrap up the drilling operations. 14 was the last location that we were going to do before shutdown to support the asbestos removal work, because 13 is essentially right next to where the asbestos was identified. Late in the day, they were pulling core from one of the deepest locations. We pulled the core, and shortly thereafter was notified by the chromatographic platform that basically a blip of solvents characteristic with what we saw in the ground showed up in the indoor airspace. Now, putting all of the pieces together, there is about 10,000 cubic feet per minute, which is being drawn into that basement space. And maybe Laurent, the next space. Yes. So in between these louvers, this is the basement space of the CPI facility. Behind these doors is a huge air compressor that supplies compressed air to the entire building, and all of their operations and machinery and the like. The drilling was taking place out here. This device basically pulling outdoor air into the space, part of the challenge. The other issue is up along this bank of windows, there were a series of air ducts and air exchangers that were also in communication with the outside ambient air. So when that source material present in the 14 core came up, it was enough to pull vapor in, and the instrumentation that's installed to do that indoor air monitoring is sensitive enough that that minuscule amount from the outdoor air being brought in essentially was enough to register. So that to us obviously was indication that we needed to do more. We needed to have a little bit more provisions in place. So in parallel with this asbestos shutdown, we've been working through the basis of both monitoring, sealing, air exchange, and changes actually to the overall HVAC balance in the building.
Thank you. Carol, can I ask you next?
Absolutely.
So my next question is regarding the TW9 borehole.
Okay.
So I was interested in the fact that so I guess my questions are sort of twofold. Were the transmissive zones identified solely on the basis of water level recovery during the Packer testing, or was there heat pulse flow meter?
Yeah, so we did.
Done?
So we started with visually inspecting, and we did downhole geophysics. So when I just said we dropped equipment down, we did calipers, we did heat pulse flow meters, optical and acoustic televiewers. So we ran a whole series of things. Based on that downhole geophysics, we selected the zones for Packer testing. So between downhole geophysics and getting VOC readings when we looked at the core.
So, for example, I see 65 to 75 and 75 to 85 as being two of the Packer zones that were tested.
Yep.
Was anything done to confirm that there was not a hydraulic connection around the Packers?
Yeah, so when we did our Packer testing, we also have some transducers in other
above,
locations.
Below, and within the,
yes,
okay,
yes.
Good. That's just
so
checking.
we've got pressure transducers there, but also in some other locations. And it was really interesting because sometimes we'll do a Packer testing and we might see a response in a transducer at another location, at another well. So it tells us if there's some type of hydraulic connection, not necessarily a flow path, but at least a hydraulic connection.
So I guess my question is, for example, like the analytical results from the 65 to 75 and 75 to 85, were they the same?
No, so I don't have them memorized, but we definitely had some that were higher than the others.
It just seems strange that you would be able to have an interval that close and not have cross connection.
And there,
Yeah.
you know, there's a possibility that there was, you know, we'll have. I was just saying there's a possibility it was, and you know, we'd have to look at the exact data to see, you know, did we see some of that in those intervals? And we can certainly look a little closer to that with you. And correct me if I'm wrong, Carol, this was the one where we saw a really wide area. And do you remember, is that like 75 to 85, the really wide area that we saw? Kind of broke it up into two sections? I can't remember.
Yeah, we had a couple areas that we had wide fractures. And when I say wide, it was like a lot of fractures or a very wide fracture. I don't remember exactly which one it is, but it'll be detailed when we go through it. We haven't even gotten the geophysical report yet, so
I'm
we're kind
excited
of
to see them.
operating. Yeah. So it was really interesting. We'd do the testing and we'd get on the phone and go through results in the evening and make decisions on where do we want to do packer testing. So it was a very dynamic process of getting all the information. So we just don't have all those reports yet. Something else you'll find interesting, there were some fractures that were horizontal. A lot of our tight fractures were pretty horizontal, but where we had some thick zones, we had some pretty steep inclining fracture
And
zones.
were they
that
dipping in the direction of the streams, or?
Not necessarily in the directions of the streams. We had them
okay.
tending
I'll
in
look
one
at it
direction,
when-
but some cross-cutting. But there were some that were like 80 degrees, like really steep, that were flowing. So it was a lot of really good information to help us with the treatment process.
I'm going to step in and recommend. So for those of you who don't know, Barrett works for a consulting firm that is employed by the city of Beverly. So he's another set of oversight and questions on behalf of the city of Beverly. And I'm going to recommend at this point that if you have further questions, you know how to get in touch with them. Is that all right? Mayor Kale, is that all right with you?
I like hearing Barrett ask questions.
Okay.
I like hearing the answers to them. So I don't mind if you.
Well, let me ask first one question we have on.
One more question.
You have one more, okay, and I do have one online as well, so I want to get to that too. Go ahead,
My
Barrett.
last question is also regarding the bedrock boreholes, and that question is: did we do a temporary seal of some kind post sampling, like a flute liner or something like that?
We did do flute liners in all of them, and interestingly, we did not see any indications of NAPL on the flute liners in
sorry, you
any
did
of
NAPL
them.
flute. Good.
Yeah, we did NAPL flute liners.
Can I ask, I'm going to add something for those who know why do we want to seal those wells is simply because if you leave a well open and you have contamination, it's going to go from one fracture to the other, and therefore by drilling a hole you may simply make things worse. So we want to seal to make sure that doesn't happen and that the borehole remains shut.
Let me just, if I could, Amy.
Okay, go ahead, Mike.
I just want to say for people's benefit who maybe haven't been at every meeting, or what I appreciate is that Barrett and his partner at Sage Engineering have been the city's licensed site professional on this job for some time now, in significant part thanks to our state representative Paracella and his counterpart Senator Lovely for getting state funds that we could put to that effort. And I will say that I want to hear all of Barrett's questions, and it's also reassuring that as Barrett and Jacob have been checking the work that all you folks have been doing, we're generally finding that we're in accord. And that's, and if we hit a point where we're not, then we'll work through that. But it is reassuring that things are being done the way that, that the people, the neighbors, the nearby, all the nearby neighbors, be they residential or schools or businesses, and the community as a whole. So I'm really appreciative of all the work that everybody's been doing on this.
Absolutely. Thank you, Mayor. And in no way do I want to shut down that communication. I don't want to imply that by any means.
I enjoy being a spectator.
Okay. I did want to get to this one question we had online, which says the mandatory report deadline was February 2024. So now is the project back on schedule? So I think this gets into, my understanding is that either a temporary solution or a permanent solution had to be submitted by February 2024. So could somebody speak
Yes,
more
and
directly to that?
and that was done. And so
The question that came up from a regulatory standpoint was, do we just continue as a temporary solution? And after consultation with the department, the gentleman who I always refer to, Mr. Fitzgerald, is the gentleman who wrote the MCP, but a significant contributor, said, no, I think what you have to do is not only continue doing your temporary solution, but for this phase 4 part, continue the phase 4 status reports for a while as well. So that's why we're doing phase 4 status reports, even though we're in temporary solution.
Okay, so and Carol added that the quick answer is yes. So the respondent was Matt Hackman, who is the LSP to the Jacobs team. He is Matt Gillis?
No, earlier I was just going to say I enjoy having Barrett sort of grill the team to see if they have answers for all of this, so I was very impressed by that.
All right, any other questions? So again, we do have that website that's at the end of the presentation. If you think of any questions, you want to submit them to us afterwards, please let us just reach out to us. Again, there's a lot of information on the website. And I believe I need to reach out to folks, but I think we'll probably schedule for that next tag meeting. Either early December, before you get too close into the holidays, and I think that Hanukkah and Christmas align very closely this year. Thanksgiving's late, so it would either be early December or into January. So I'll reach out and we'll schedule that next tag meeting. Well, thank you everybody for your time. I appreciate you coming out. Again, this presentation will be posted on our website. Have a safe drive home.